Hello, and welcome to the last talk of the day. It's always a little bit interesting to be the last speaker, so I'm glad to see you haven't gone home, all of you. Now I'm just going to try to keep you awake. I actually have the opportunity to tell you something that you're going to remember, because it's going to be the last thing you hear. So I'm going to try to actually talk a little bit about microservices in a way that makes you think a little bit. I've been listening to Michelle's talk here today. She's done a couple of talks on microservices and Docker, and she has a sort of a different approach to it than I have. So if any one of you have listened to those talks, I might be saying things that she would disagree with. And I expect that you would go home and think about it and maybe make up your own mind. So I work at a small company. I've been doing microservices and SOA architecture for about 10 years. It's a small company in Denmark, actually. We do a virtual waiting room that sort of prevents huge websites or ticket sites or such to breaking down when there's a peak in traffic. It doesn't really matter a lot, but I assume you all know at least have some basic knowledge about what microservices are. Basically, you can have this monolith style of building your application, and in this case, a virtual waiting room service. If you don't sort of understand what that is, just think Netflix. There's Netflix, streaming stuff. And then you can split it up into these smaller microservices that you can deploy and manage individually. So who here is doing some sort of microservices? So that's quite a few of you, actually. Who here would like to do, and you have to be honest? Yeah, so that combined, that's pretty much every one of you, or at least 90% or so, which I sort of expected. There's a lot of hype around microservices, right? This is sort of the new thing, and all the cool companies are doing it and they are promoting it. And they're sort of awesome, right? In many ways, especially to developers. So I think it's sort of interesting to explore why we think that they are so awesome. It's even in the words that we use. So we have a monolith and you have microservices. So I'm from Europe and Denmark, and we don't really like anything that is centralized. I mean, or big or anything. I can have an argument with my boss that he's gonna give me a raise, right? So we like decentralized things. So even before we sort of start talking about what they are about, then we already have some sort of opinion about it. So in this case here, it's pretty much the same as talking about the Death Star and the Rebel fleet. Who do we like? Yeah. I think that's one reason why it's so interesting. Another reason is that we've all tried this layered architecture, and over time, in the beginning it's sort of nicely layered and you can reason about it and understand what happens when you change something. And eventually, you're going to have these dependencies across your application, and so when you change something here, something is going to blow up over here. I think we've all had that experience, or at least a lot of us. And sort of microservices promises to make these smaller independent units that you sort of don't have that issue. Even if you have sort of a really nicely layered architecture and you don't have these dependencies across your lanes here, you're still going to have a database that is shared amongst everybody. So you're still going to do nasty things to the database, querying data that doesn't really belong to that part of the application. Another reason is that we as developers, I don't know how many are developers, but I am, we like complexity. Not the kind of complexity that we just talked about, but the sort of technology complexity, your tools and frameworks and services and sign patterns and that sort of complexity. That's what we sort of think is funny about the work. If we did the same thing every day, we would sort of be bored. Also, it makes us, go to these sort of conferences where we learn new stuff, right? And we also love to talk about new technology here, right? It's, the more complex it is, the more interesting it is. So we're sort of drawn to this complexity, and microservices has a lot of complexity. I mean, there's a lot of dimensions that are added to microservice, or to the whole technology scope in microservices. But I think, for me, mostly it's the promises of these decoupled and independent services. Now, in all my professional career, I've been taught that we should, minimize dependencies between our software, our modules that we do. We have to have high cohesion, right? And decoupled modules. So this is something that we've been learned that we need. And it's actually a very nice promise, and it does also fulfill that promise if you do it right. So this is, go for it. Let's just do it. It's sort of awesome, right? What we sort of sometimes forget to think about is that, is this actually valuable to us? I mean, we are in his hype, and we think everything is awesome and great. But is it valuable? And I'm not sort of thinking about from a technical perspective, because you can always argue that the tools and the disciplines we use in microservices, they are valuable. But translating that into some business value is a little bit more difficult. We should also explore what the trade-offs are, because there are a lot of trade-offs. And again, also pitfalls. So what can go wrong while we're doing this? So, is it valuable? Now, if you need to sort of answer that question, we need to know what is the value that the microservices bring. And when we start to explore that, it sort of becomes apparent that it's not a technical one that is the primary reason why we do microservices. It's a people one. Okay, microservices come from companies like Netflix or Airbnb or all the big ones that have thousands of employees. They have a people problem. They need to figure out how to get thousands of people to work on the same product. So the sort of solution for this is all, of course, these cross-functional teams that are individual and that can take a task and deliver on that task by themselves without having any sort of dependencies on other teams. And that is really what microservices allow. So all the things, the technical solutions we have to this problem is mostly about scaling the organization. So once we know that, I don't think a lot of us are working at Netflix or a company in that size. So what if we are a smaller team? Can we benefit from doing microservices? Yes, probably. But I think you would need to have some special requirements. So for instance, for us, we are like 12 people on the development team. But we have some very unique, or not unique, but at least quite serious problems with scaling and availability. So for us, it makes sense to actually have a microservice architecture. When you have that architecture, it's so much easier to scale, because typically you don't need to scale the entire application. You just sort of need to scale a corner of it. So if you have small services that just sort of serve that corner, then it's easier to scale it. Same goes for availability and reliability. So we can't be down sort of ever. That's not an option to do that, because we sort of live from being available when our customers are down. So it's easier to build an available and reliable system if you have microservices. Then there can be other requirements like technology. So do you need to use different types of programming languages? C, for instance, to do something very performance-laden programs. You probably don't want to write everything in C, so you sort of have requirements for using multiple programming languages. Maybe you have different data stores underneath. Okay, so maybe you don't have any of these requirements. So can you still benefit from doing a microservice architecture? You know, probably not, I would say. But there are a lot of the disciplines and sort of ideas around microservices that you definitely can improve your application. So what are these trade-offs you keep talking about? I've been at a number of these conferences here, and there are a lot of speakers, right? We talk about what you should and should not do. We don't really talk about what the trade-offs are. And there are quite a lot of them. So most of them are around the deployment, the operation, and the test. Oh, sorry, the development and the operation and the test and debug monitoring areas. So as a developer, you have to sort of, all of a sudden, there's a lot of different practices that you all of a sudden have to do that you didn't have to do before, or at least you have to do it in a smaller scale. You have any number of repositories, like you might have 25 or 100 or 1,000 repositories all of a sudden. All of these have projects. You need to create build and deployment pipelines for them. It might be in different languages, so it's not just copy-paste thing. You can use the same template for everything. You have installation script. You need to bootstrap some of the servers maybe. And because of this, the size and the scale of it, it's really, really important that you sort of get it very, very detailed, right? So the deployment pipeline, for instance, it's not about just having a continuous integration server that runs some unit tests. You sort of have to go all the way so that you can test and deploy your systems with like a few click of a button or something like that. So there's a lot of time and effort that goes into actually building this. And so when speakers and blog posts and whatever you read sort of describe this, they will say something like what I have to say here. You have to do it right, but it takes a lot of time. If you're only a few people, it's just very difficult to actually get some business value out of it. There are other things the developer needs to take care of. We all of a sudden have a very advanced network layer that we need to deal with. So we have APIs and DTOs and serialization and REST and asynchronous messaging, which is really important. And on top of that, you have to deal with all kinds of new error scenarios in the I/O and with latency and errors. So a small latency in one service can actually have a huge impact on a service in a different part of the application. So there's a lot to deal with here. Again, multiple programming languages. You have frameworks and tools to sort of support all of this complexity that is added to your process. You have multiple services and data stores that needs to be used. So there's a lot of things to learn and a lot of things to master all of a sudden, if you sort of want to reach the full potential anyway. Then there's debugging. Debugging is not as easy anymore. You sort of used to be able to debug in your IDE. Now you have to sort of set everything up either on your local machine or you have to do it somewhere in the cloud maybe. You don't have full stack trace of what's going on. So debugging becomes a bit more complicated than it was before. You have versioning. So because you have these individual teams, you're releasing a version of your API, you can't just tell other teams to go and update that version. So you will always have at least one, of course, but probably multiple versions of your API that you need to support. You have availability and redundancy. I'm going to go into that a little bit deeper later, but that's sort of things you need to worry about as well, that maybe you didn't have to worry about so much before in the monolith. Then you have operations. Again, this is, there you go. This is mostly a factor of the multiple services. Now, your operations team, if you have one of those, they can't just monitor one service anymore. They have multiple services that they need to have, that they need to manage in their system. They have they have new technologies as well. You're likely to use some cloud technology or some container technology to make this work. The operations team will need to be able to support this as well. Then there's a lot more error cases for the operations team. So there's this whole new layer of network that they need to be able to respond to. And these errors here, they sort of cause these strange error cases deeper down the system. For instance, if there's just a little bit of latency, it can cause some very serious problems somewhere else in the system. So troubleshooting also becomes much more painful. You have to know a lot more about the system than you had before in order to be effective in this. Then there's monitoring. You're not monitoring one service. You're also monitoring 100 services. You're also monitoring network, all kinds of things that you need to look into. Logging, simple thing, right? Usually you log to some drive somewhere, and then you can maybe import it into some tool. Now you have 100 services running somewhere on some Docker thing. You need to get this logging data into some centralized storage. You have distributed tracing, so if you have any transaction, like an order, that transaction is bound to go through multiple services. So just getting the logs correlated to each other is a thing that you didn't have to think about before. So again, the extra load on the operations team will probably mean that you need to transition into this DevOps principles instead. So you actually get your developers to be operational people, or at least hire someone that can both do development and operation. And that's simply because you have all these new error scenarios. So just handing your code onto the operations team is becoming more difficult. Then there's test and debugging. I said a little bit about debugging, right? But you have these multiple services. You can't just hit F5. Maybe you can't actually host the entire application on your own device or your own computer. So you might need environments to support this. In either case, whether you do it on your own laptop or on some test environment somewhere, it's going to be complex. So, but just setting this up and managing it and preparing data for it and running tests and all that is just a lot more painful. Yeah. Another part of testing is that unit tests, they don't really have as much value anymore because all of your code is sort of spread across multiple services. So you need to do something else. You need to have a higher focus on doing integrations tests. Integrations tests are sort of brittle. They fail due to various reasons, and they are actually harder to implement. So that will take you more time to do. You might even need to introduce some new principles, like some new practices, like chaos engineering. It's pretty cool word, but it does actually, the thing is that if you have a microservice architecture, you have these error scenarios that are sort of hard to predict. Like, yeah, again, with the network, you have multiple different data stores, so maybe, if one of them goes down, does your entire application go down? So chaos engineering is this way of exposing these errors before they happen. The same thing with site reliability engineering. But we have all these new practices that you sort of have to at least think about. So pitfalls. So what can go wrong here? Michelle talked a little bit about pitfalls as well. It's really easy to build a system, a microservice system, that is worse than what you had before. There are so many things that can go wrong along the way, especially if you do not have any skilled people on your team. So if you try to do microservices with a couple of junior developers and a offshore development team or something, it's likely that you're going to get hurt. Even with skilled people, I would say you would need to practice. It's not something that you sort of just jump into and then think that everything is going to go well. I'm going to come back to the practice part a little bit later on. But yeah, really important. Also, if you sort of start on the path of having multiple programming languages and multiple services, actually doing this, I mean, one of the benefits of microservices is that you can sort of pick the right tool for the job. But when you do that, you just require more of your development team. So that's important to realize that and only hire some skilled people, right? So be aware of the distributed monolith. That's a cool word, distributed monolith. So the distributed monolith is the situation where you have dependencies between your services. They're supposed to be independent, but you end up in a situation where they are actually dependent on each other. And when they are dependent on each other, then the teams are also dependent on each other. And then you sort of lose the ability to scale the organization. So this can, for example, be that you have a shared model across your services. You have a shared database across your services. So basically, if you change something in the data structure, then you would need to change the model in all of the services. Also, let's say you do have a microservice in front of it. The team for the microservice has actually been kind enough to make an SDK that the other teams can use to call the microservices. Let's then say there's a business requirement, and the team sort of chooses to put in this feature, this performance optimization, or whatever it is, in the SDK. Then that SDK is distributed to 20 other teams that puts it into 50 other services. And now there's actually an error in there, a critical error in this SDK. So what do? You have to go out to 20 different teams and get them to update 50 different applications with this SDK. So you have a very tight coupling, even though you actually made a microservice. So these are things to be aware of, especially if you need to scale the organization. Don't have these dependencies. And this is really also comes down to this don't repeat yourself principles that we've been taught for the last 30 years or 40 years. Microservices is sort of in a direct conflict with that. If you put shared code in some library that everybody depends on, then you have a dependency between the teams. So I'm not saying that you shouldn't do it, but sometimes it's just better to actually copy the code than it is to share it in a shared library. And that goes sort of against everything we've been taught. So, Michelle, if you saw the previous talk, and the one before that, and the one before that, talks a lot about eventually consistency. And this is extremely important. So the way you decouple the services is by using messaging. Instead of actually having a RDP call to other services like REST or similar, then you need to do an asynchronous way as much as possible. Let's say you have an order, and that order goes into the order system. Then there's a fulfillment system. You don't need to actually send a REST message to this fulfillment system, because now you have a tight coupling between those two systems. If the fulfillment system is not available for whatever reason, then your order will fail. Instead, if you take that command you have to the fulfillment system and put it in a message queue or a message broker or whatever we should call it, then the fulfillment service can pick up that message and do what it needs to do whenever it is available. So this is also a way of both a way of decoupling the systems, but also a way of actually making them available. So very important, you need to embrace this. And this is sort of probably a discussion most teams have, if this eventually consistency is really a good idea. But if you want to succeed with microservices, you have to do it. There's sort of no way around it. And even, it's sort of imposed on you anyway, because if you're in the cloud or if you're using a NoSQL database or any other service almost except for a relational database, then you have eventually consistency anyway. Okay, so here's one of the tough ones. Your organization may need to change. So if you're sort of in a traditional organization, you will have some database experts sitting over here in a silo. You'll have operations team, you'll have some front-end guys, you'll have some back-end guys in different silos. If you want the organization to scale, then these guys need to talk together. And the more people that needs to talk together across these boundaries, the more dependencies you have. So this is the part about having these cross-functional teams. That is sort of the base success, the base reason for success of Netflix and the other big corporations. So this is difficult to do. I mean, especially if you are in a large company. I'm lucky enough to be in a startup, so we sort of did this from the beginning. Oops. Another one that is really important and is really tricky. This is the part about bounded context and domains. So bounded context is the way that we should separate the services from each other. Michelle talked about it last time, so last talk here, but for those of you that didn't hear it, is trying to find these natural boundaries in your organization. So you might have a subscription part of your organization. You might have a billing, and you might have a identity management. These are sort of natural boundaries in your organization and in your system. So this is where we want to split the microservices. Now, the tricky part about this is that if you sort of are starting on a project, you don't really know your domain. Like, for instance, where I work, we have this virtual waiting room, and we thought in the beginning, 8 years ago, that this service should be available to anyone. It should be a sort of a free service that everybody can install on their websites. It took us like 4 or 5 years to figure out that this product is actually mostly interesting to huge corporations. And that sort of changed the entire domain of what we were doing. We thought we should do social media integration and that sort of stuff, but what the corporations wanted was reporting, and it was security and all that stuff. So the point is here that refactoring a microservice, one microservice is easy, it's small, and you can actually just throw it away, build a new one pretty easily. But if you want to refactor between these boundaries, between microservices, you all of a sudden have a huge problem because you have contracts between these services that needs to be changed, you have data models that needs to be changed. Everything just gets really, really complex. And so the problem is that you cannot really define these boundaries until you know your domain. And at that time, if you already have sort of settled on a microservice architecture, then it's too late because you're likely to have messed it up. So I'm going to probably talk a little bit more about that as well. But it's really, really important before you begin. You sit down and you learn these things. Look for DDD, this domain-driven design. These concepts are from domain-driven design, and they have practices to sort of explore your domain by using these domain events and figuring out what aggregates they belong to and so forth. Okay, here's another one that can get interesting. Availability and reliability. So it's fairly easy to have a monolith with a reasonable availability. So if you want to go for a 1.9 or 2.9s, you can sort of do that in a monolith. The thing is, if you separate that monolith into, let's say, 4 critical services that each have, a reasonable availability. In this case, the one with the worst availability is 99.3%. Then you should think that, this application is as good as the weakest link, so the availability must be 99.3%. In fact, there's a little bit of math to it, but in fact, it's a function of the 4. So you're going to end up with a availability which is much lower. So this is the reason why you sort of need to think about availability and reliability when you do a microservice architecture. And there are, of course, ways of working on this by using this message passing and also doing redundancy in your services, of course. And if you do that, it's possible to get a system that is very reliable and very available. But if you don't think about it, it's probably going to be worse than what you had. Okay, so what do you think about microservices now? Still like it? A little bit. I think they're amazing. You should definitely go for it. Just start flying. There are a lot of good things about microservices. And especially the practices that sort of make up microservices. For me, microservices are sort of just some things that we already knew, like having this low coupling and doing things that are sort of individual, does one thing really, really good. These are things that we've sort of known for many, many years. There's nothing new to that. What sort of is new that we have some tools and we have some frameworks and some infrastructure, like in the cloud or Docker or whatever it is. The open source tools that sort of support this all of a sudden. So it's sort of feasible to do it. So despite of all this, it might still be a good idea to do it, even though you're a small team. The sort of where it's a little bit, I'm a little bit two-faced on this, is that all the speakers I've ever heard about microservices sort of educate us on that there's a lot of things that we cannot do. We have to do things in a certain way. We have to be aware of a lot of things, and we have to do everything right. And all of these things that I just showed you, they just take a lot of time. And that's time you take away from actually providing business value. So for me, it's sort of about imperfection, right? So most of us are not Netflix. If you were Netflix, you would have to do everything by the book, and you would actually also gain from that because you would be able to realize the potential that Microservices promises. Because you have this large organization, you have scaling issues, you have the whole thing. You need to be reliable. You know, if on the other hand, if you're just one person, you know, you're probably not, you know, going to build any system at all because you're going to spend all your time on all the technical part of it. Most of us are sort of in between somewhere, right? Whether we are 10 developers or 20 or 50 on a given project, we're sort of in between where we can realize the full potential, but we can still benefit from some of it, right? This is sort of a little bit, you know, again, developers, when we sort of see something that is imperfect, that's not great. We sort of tend to sit down and refactor, right? It's like my girlfriend at home. She's sort of vacuuming the house like twice a day or something. And you know, sometimes I want to make her happy, so I vacuum the floor before she gets home. And the first thing she does when she gets home is start vacuuming, right? So this is this sort of perfection thing. Everything needs to be sort of really, really perfect. And I'm sure you sort of had this experience before where you look at some code you wrote maybe a year ago or someone else wrote, and you think, what the hell is this? I need to refactor, right? I'm going to sit down 5 hours refactoring this because it looks like, yeah. And you know, it doesn't provide any business value at all, but you know, have to do it. And I'm not saying that's necessarily a bad thing, because we would like to keep our code clean, and we would like to, you know, sort of meet our standards. But at some point, right, the value of doing it doesn't really make sense compared to the effort that we put into it. I think that's very key to microservices. You sort of have to make some, you know, decisions about what is it that you would like to focus on. What is the parts of microservices that make sense in your context? Who likes Scrum? One, two. There's a couple of people who like Scrum. There's a couple of things that I don't like about Scrum, right? One of the things is that you can hire this consultant who comes out, and he says something like, maybe he's called an agile coach or something, but what he's going to say is that I can create these hyper-productive teams for you. It's like ×3 of what you normally see. The only thing you have to do is to not deviate from Scrum. Maybe not the only thing, but you don't deviate from Scrum, right? That sort of starts my bell stops. You know, that's wrong. It's not putting things into context. Just putting things down, you know, dragging things over, principles over some organization will not make it better, just because it's some book says it. The same thing I feel about microservices. So, then we have this term here, monolith first. And it is, as it says, actually, build a monolith first. And you're going like, he's crazy. You want me to build a monolith just to split it up into microservices? Yes, I guess. That's what I'm saying. And this is for reasons that I sort of already spoke a little bit about. The thing about the bounded context and the domain. If you don't know the domain, you're likely to get it wrong. And once you get it wrong, you have to refactor it. That's expensive. So you sort of pay the expense anyway. Even though it's not a monolith, you have to refactor it into something that you didn't think it should be. Secondly, I mean, at least if you're a startup, or in many cases, you build this MVP, right, the minimal viable product. And the purpose of this first version of your system is actually to learn, right? You need to build the minimum thing that makes value, that gives value to your end users, while you can learn stuff from it. If you have to do all of the things that I just showed you on these slides, would that be a minimal viable product? No. I mean, you wouldn't learn anything from shipping your logs to some centralized log storage. Not about the business anyway. It doesn't bring any value to the end user. You wouldn't learn anything from it. Whether you would learn something from it, but you wouldn't learn whether your users would actually love the product that you're building. So you might end spending a lot of time on doing all of these things that are required by microservices, just to find out, that nobody wants to use your product. So the idea here, and actually this is not something I have come up with. You can go to Martin Fowler's website, blog, and he will say the same thing. And actually, all the stories you hear from Airbnb and Netflix, they all started with a monolith that they broke up. And yes, that takes time, it takes years to do. And it's probably difficult because you've already made this mess that I showed you with the dependencies. So you need to straighten that out. You need to introduce all kinds of things. It takes a long time. But the good thing about that is that you get to practice, because this is not easy to do. You have to sort of have these skilled people, and while you're doing this, you're actually practicing doing it. So the way you could do it is to start picking off pieces of this monolith you have. For instance, identify places where it hurts. And these places are typically the ones that have multiple dependencies. So if you have dependencies throughout your system to some module, it could be, for instance, a reporting module that everybody wants to send data to. Then that will probably start hurting a bit. Now you can take that out, put it into a separate service. The good thing now is you know your bounded context, you know your domain, so you can do that. And you have a fairly high certainty that you don't have to redo it. You could also look for key services, like, for instance, the identity management service. Now, if you pull that out into a separate service, it might be a lot easier to do some of the other services, because you have aggregates in place and you have messaging around that very central piece of code. That will help you when you sort of start some of the other areas. If you want to practice, you can look for low risk. Good candidate could be some report that you generate in some, let's say, web server. Who done that? I have. A couple of people done that. You sort of probably know that having this long running process of building PDFs and maybe even integrating with Word or some crazy thing like that in a web server is not a good idea, because it'll block all the threads, and the technology is just not built for that. So that would be a good thing to identify. Also, it might not be very, may or may not be, but there's a chance that it's sort of a low-risk thing. If it doesn't work for half an hour or something, then people will get their report eventually. And then, of course, if you have new requirements, so let's say something changes dramatically in your requirements, then rather than changing it in the monolith, you can just build a new one. Once that's sort of built, then switch your monolith to use that one instead. I'm sure there are other ways of doing it. So again, it's a context thing, what you would like to do. Yeah, so another thing you could do, if you don't want to sort of go into a full-blown microservice architecture, and you're not, you're not sort of a great big team, then you could look for these bounded contexts and think them into your architecture. So we had this one here. I talked about it a couple of times. What we sort of usually do here when we have this situation of these dependencies across the entire application is we sort of introduce a new layer, right? So we're going to put in a new layer that will sort of abstract some of this away and makes, what layers really do is just for humans to reason about the code. Now, the computer doesn't care about layers. It's just for us, so we can talk about it and we can understand the code. So we put in more and more layers. And I don't know if any one of you have tried it, but at least I have, or at least my boss has. So my boss will come up to one of the developers and say something like, hey, can you add this field to the database and just make a simple input box in the UI and then flow the data into it? And the developer says, yes, I can do that. It'll take me 3 days because I need to translate between DTOs and models and make unit tests for that and do all kinds of stuff in layers and what do I know. So if you instead think this bounded context, think these bounded contexts into your architecture, then you can actually make it an architecture that's much more clean. So what you do is you take away all of these, you sort of think about what areas of my applications do I have? Like maybe I have a product catalog, maybe I have a cart, an order system, fulfillment system, and user management or whatever. Just like you would do with microservices. And then you separate your application. It's still the same, one application, it's still a monolith, it's still running in one process maybe, or a few processes. But the point here is that the communication between these boundaries gets to be very defined. You have this contract first idea, so you create a contract to be able to communicate between the different parts of the application. So all of a sudden, it's much more clean how your architecture is created or is developed. And you can do this in the same application. You could do it as namespaces or modules or whatever you would like to do, as long as you sort of have these rules and you apply the rules, of course, that you cannot do communication between the different contexts, except for the API that you have defined. So if at some point you decide, okay, this particular part of the application, like reporting or whatever it is, you would like to pull that out into a separate service that runs on a separate hardware or a separate process, then it's pretty easy to do that because all you have to do is to change the API that was once in process to something that is out of process, a message queue or REST or whatever. And then take the code and put it into a separate service and make sure it's deployed somewhere. The point about doing this is, of course, that while you have everything in process, you sort of don't have all the trade-offs that I talked about. You don't need to worry about logging in the same way. You don't need to worry about debugging and testing. You can still have your sort of unit test that runs maybe even cross the boundaries. So it's a lot more easy. You don't get the pain, or not the pain, because we love all the technology and all the decisions that we need to do, but you don't get that complexity, and you're able to actually focus what really matters for the business, while you still have a clean architecture that is easy to reason about. All right. So, what are sort of the minimum requirements to get started on this? So I'll say there's a couple of things that you need to get if you want to do microservices, and I think you should if you have the requirements for it. Then there's a couple of things that you need to take care of. One of them, we talked about it already. You need to have a decent deployment pipeline, so continuous delivery of some kind. It doesn't have to be perfect, but at least you need to be able to deploy your services in a predictable manner. And it should be something that is done fairly quickly, so you can use it for your test environments and that. there's sort of no one way to do this, but it just takes time. I mean, it takes longer than you expect. It sounds really, really nice with all the slides you've seen today, probably, of how you should do this, and you can build Docker images in your CI, and it can sort of go to a repository, and it can magically appear somewhere. But it's just not. In practice, it takes longer, right? But it's also really, really important that you have it up front, because if you don't do it, you're going to spend a lot more time on things that should have been automated in the first place. So definitely recommendation. If you need to spend a week doing this when you start, then you should spend a week on that, because the time will be repaid afterwards. Yep, development environments. There's a bit back and forth on that. Should you have everything locally on your box so you can debug it? Maybe you want to do that in the beginning of the project, but eventually I think you'll find that it's not sort of a scalable way of doing it. So I would recommend that you have separate environments that are available for development that users can, or your developers, you, can use as you debug and you test and that sort. And one of the reasons is that, especially if you're in the cloud, is that some of the services that you might use, like, so we are on AWS, so that would be Dynamo, or it would be SNS, or any Aurora, or whatever it is. Many of those services don't actually have a proxy or something that you can install locally. So you sort of need to use the ones on the real production one, or not the production ones, but the ones running on AWS. So actually running everything locally is not possible to do, unless you sort of spend a lot of time on creating stubs for it, which I don't think make any sense. So you're sort of forced to do that. But again, it's something that is up for discussion, of course, whether you should do one or the other. It totally depends on the context. For us, we are so invested in Amazon and all the services that it's just not possible to do. So automate this stuff, make sure it's available for developers to use, otherwise your velocity will just drop. Then there's logging and monitoring. This sort of thing should really be in place until you go, before you go into production, right? At least some basic parts of it. I think what we do is that, monitoring is really a part of the definition of done. So I said I didn't like Scrum, but definition of done is probably a good thing. So before something can be deployed to production, we should make sure that we have all the monitoring and alerts and escalation on that. Again, logging, make sure that your logs are sent to some centralized storage. There are lots and lots and lots of services out there that can do it for a decent amount of money. You don't have to sort of build it yourself. In fact, I'm not sure why you would build it yourself. Send it to Logly or whatever service you would like to use. They do a lot better job at it, I'm sure, unless you're sort of a huge organization that have people to do it. Anyway, really, really important. If you don't have this sort of in place, as I said, there's all of these error scenarios that can sort of pop up and will pop up that you didn't imagine would be there. So if you don't have some system that can actually alert you on this and maybe even self-heal, then you're sort of in problem. So here's the thing that is, I think, also important. Choosing technology is always fun, right? The thing is that the choices you make on technology will have a huge impact on the amount of work you need to do on these things that sort of are part of microservices. So if you don't have an operations team with sort of experience with Docker or similar technology, then, and you're not in the cloud, then you should probably think about not doing microservices. I mean, The cloud or Docker and these tools here will just help you enormously. They will provide a lot of these different things that you need in order to automate things. So we have a principle that says something like, when we need to develop a new service, we will look at it and see, okay, can we run this serverless? Again, we are this small team, so if we need to spend a lot of time on actually running our software, then we don't have time for doing business value. So if you sort of deploy things serverless, you get a lot of things for free. Scaling and availability and logging and all these things here, or at least a lot of these things. Even deployment is something that is sort of easier or out of the box. If we can't do serverless, then the next choice should be a container of some kind. And this, I mean, again, if you're a small company like us, it's sort of difficult because Docker is this huge critical piece of a technology. If you have to run that on your own, it requires some serious skills. Now, luckily, the last year or so or two, the cloud has been, AWS and Microsoft have been really great at releasing new services that makes it easy. So on AWS at least you have Fargate, and basically here now all you need to do is create your image, ship it to AWS, and they will make sure that it's deployed on some cluster somewhere that you don't really care about, or maybe not care about. Takes away a lot of complexity. Then the next thing we do, so we can't deploy it on serverless and not on Docker, then there's some serious reason why it should go on an EC2 instance or even a dedicated instance. It might be worth actually thinking about how can we change our application so that we can deploy it into serverless or Docker. When you sort of deploy it on a virtual instance, you get a lot of the complexity that you need to handle yourself. So AWS will of course help you with some of the things, or Microsoft Azure will help you with some of the things, but a lot of things are left and you need to deal with, such as auto-scaling. They might help you, but you still need to sort of create an application that you can auto-scale, really. Bootstrap itself, you need to sort of get the data, the binaries and the configuration from some repository somewhere, and then make sure that it's installed on the server, and you need to patch the OS and all that stuff. It just takes time. And it takes time away from doing something that is valuable to the business. So, yeah, so if you want to so one of the things that Michelle talked about just in the previous talk was that you have to convince the business that this is a good idea. So if you start spending a lot of time on doing all of these things that doesn't provide any business value, and the business cannot see that they're getting any value from the time that it's spent, then they're probably going to shut it down. If you choose serverless, for instance, you can quite easily get running in a very short time. And that's sort of a way of showing the business that, okay, here's the value that we provided in a very short time, and you might, actually succeed on it. Technology is more than just the infrastructure, of course. It's also programming languages and services and open source frameworks and whatever. It might be a good idea to sort of in the beginning, while you're learning, actually just restricting it a little bit. So saying, we'll start with these services, we'll learn them, and then, as we practice and get better, we'll drag more things into this, whatever makes sense. We are at the point sort of where we've been for a while, where we say anything that Amazon has built, we're going to use if it fits in. And that just increases velocity by a factor of 3 or something. But it does require that you are sort of ready for it. again, also with programming languages, it's sort of very tempting to say, okay, I would like to use Scala for this particular problem here, but if you only have one person that knows Scala, or two, then it might not be a good idea. Because what if they leave? Then you have a development team that sort of sits with a service that they cannot maintain. So there are sort of multiple aspects into this. Obviously, if you're a larger team, or multiple teams, then it starts to make sense, because you can sort of maybe utilize, let's say, developers that know PHP for something, and other developers that know C for something else. Yeah, and then one of the big, important things to have when you get started is to have some asynchronous messaging technology available to you. The risk is sort of that you fall into this, we'll just do REST and everything. And one of the things that sort of made SOA go bad was that we had web services. So we did remote procedure calls, RPC, to actually invoke our services, so they became very tightly coupled. Now REST is also an RPC. So there's no real distinction between, there is of course a distinction, but basically, web services and REST are sort of the same thing. It's still synchronous calls made. So if you don't have this from the beginning, you sort of risk having a very brittle system at the end, because you might never introduce it, right? You just get accustomed to doing this REST. Everything you do between these boundaries of the services, the bounded context, you should try to do it in an asynchronous manner. So again, bounded context, core domain. I talked about bounded context, but basically the core domain in your, if you know DDD, there's the core domain, the different subdomains. So the core subdomain, and then you have supporting subdomains, and you have generic subdomains. The core domain is where you make your money, right? Supporting domains could be things that sort of doesn't really distinguish you from your competitors or other companies, but they are sort of necessary for your service to work. And then you have supporting things like supporting subdomains like your support functionality. That's just something that you want to pull out of, you maybe want to buy, right? Like logging repositories could be an example. So the point here is, and it's also the point in DDD, is that you don't apply DDD to all of your subdomains. You apply them where they actually give value. And that's because DDD is difficult. It has the same problems that microservices have. It requires skilled people and requires time. It's just hard to do. So you apply it where it brings value. And I think the same is the case for microservices. There's no reason why you would build everything in microservices. I mean, you might have some part of your core domain, or the core domain that you do it this way, and other parts of your application that does it in a more monolithic version of it. So if you take anything away from this talk, I think you should go buy a book on domain-driven design and read it, understand the concepts. Even if you're not, doing DDD or you're not doing microservices, there are still a lot of principles in there that are really, really helpful to know. Yep. Enjoy, I would say. I think they are awesome. I mean, you get a lot of benefits from doing microservices. There are some pains. You can reduce them locally. When we started 7-8 years ago, there wasn't really a lot of tooling for this. The cloud providers didn't really have any functionality that supported microservices. Nowadays, you have Docker, you have auto-scaling, you have serverless, you have a lot of different things that makes it really, really, not really easy, but at least easier. And the benefits that you sort of get from microservices are easier to gain. So I think, if you have some of the requirements that are sort of matching the benefits of microservices, it doesn't have to be the scale of the organization. Definitely, if you have that, microservices is a good thing. But even if you don't, there are still things that you can take away from microservices. You probably don't want to implement everything. We certainly haven't done that. One of the things is that we still have a shared model across some of our services. And you go like, dude, that's wrong, right? Everybody will say that's wrong. I even said it before, it's a distributed monolith. But we sort of have the situation where our model is quite simple. There's not a lot to it, really. And it doesn't really change a lot, and we're a small team. So having a shared model and a shared data layer across our services actually makes our velocity much faster because we don't have to deal with a lot of network traffic and serialization and all that stuff. As we grow, it starts to be painful. We get into situations where we have these dependencies across services. There's some error or some model that needs to change, and you sort of have to change it in multiple places. And you have to deploy. Then you sort of have to deploy everything as a whole, or you have to somehow, if it's a critical service that needs to run all the time, you have to do it in steps, right? You change the model, then deploy it, and then you have to change the model. You remove the old stuff and deploy it. And so you have this multi-step thing, and it just takes a week to do. Those are the sort of the dependencies you don't want to have. And when you start hurting, you refactor, right? You start separating the data layer into smaller models that fits the microservices you have. So, this thing about imperfection, I think is really, really important, unless you are, in fact, Netflix. And, it's amazing. Go for it. Thank you. I don't know if I am on time or anything, but hope you had a good conference.